Welcome to Master Concepts in Chemistry. In this lesson, we will discuss how to use a chemical equation to convert from moles of one chemical to moles of another in stoichiometry. So to start, you need to make sure the given chemical equation is balanced. Once it's balanced, you then proceed to interpret the coefficients of the chemicals in the equation in terms of moles. Then after the interpretation, you then proceed to write mole-mole ratio between the chemicals of interest. So let's say we are given moles of chemical A and we are asked to figure out moles of chemical B using the chemical equation. So first, once we've written the mole-mole ratio, this mole-mole ratio, mole B over mole A, it's from the chemical equation. So from chemical equation. So this mole-mole ratio, mole B over mole A, is from the chemical equation. And the mole A is what is given to you in the problem. So this is given. So once you interpret your chemical equation in terms of moles, and you write the mole-mole ratio between A and B, then what you do is you multiply the given moles in the problem by the mole ratio from the chemical equation, which is moles of B divided by moles of A. And once you do, the moles from A in the given problem cancels out the moles of A from the chemical equation. So you are now left with just moles of your B. And that is what you want. So let's proceed to look at a problem. So this is a problem. It says calculate how many moles of sulfur are needed to react with 1.42 moles of iron. So the 1.42 moles of iron is what is given in the problem. And this is a chemical equation. So first, we have to make sure the equation is balanced. So in every chemical equation, you always have a reactant side and a product side. So here we have our reactant side. So we have iron and sulfur reacting to make iron trisulfide. So we have to check we have the same number of atoms on both sides of our equation. So on the reactant side, we have 2 atoms of iron. On the product side, we have 2 atoms of iron, because there's a 2 here, there's a 2 by iron. Also, we have 3 atoms of sulfur, and on the product side, we have 3 atoms of sulfur. So our equation is balanced. So we now proceed to interpret our equation in terms of moles. And this interpretation is just interpreting the numbers in front of each chemical in terms of moles. Remember, when there's no number in front of a chemical in the equation, 1 is implied. So here we have 1 in front of iron trisulfide. So we'll say 2 moles of iron reacts with 3 moles of sulfur to produce 1 mole of iron trisulfide. So this is our interpretation. So you see the 2 in front of the iron, the 3 in front of the sulfur, and the 1 in front of your iron trisulfide. So now, our chemicals of interest are sulfur and iron. So 2 moles of iron to 3 moles of sulfur. So we write our mole-mole ratio. So our first mole-mole ratio is going to be 2 moles of iron divided by 3 moles of sulfur. So I'll call this conversion factor A, or mole-mole ratio A. Then B, mole-mole ratio B, or conversion factor B, will be 3 moles of sulfur over 2 moles of iron. So what I've done is, conversion factor B is just a flip of conversion factor A. So just like we saw in unit conversions and also in the mole concept, it's the same principle. So now we have our conversion factor. So we now proceed to draw a table. So this is our table. And remember, top left, that is where we write what is given to us in the problem. So we are given 1.42 moles of iron. And what we want, we write it top right. So we want moles of sulfur. So meaning the bottom should be moles of iron. Now we need to put numbers in front of our moles of sulfur and the moles of iron. So that is our mole-mole ratio from the chemical equation. So we look at the 2 ratios that we wrote, ratio A and ratio B. Which one do we have moles of sulfur on top? Because our table, we want moles of sulfur. So that is this ratio. So we'll put a 3 here and we'll put a 2 there. Then we'll close our table. So you see, the moles of iron will cancel out the moles of iron. So what we are left with is just moles of sulfur. So we multiply 1.42 by 3 divided by 2. And once we do, we'll get 2.1 2.13 moles of sulfur. So that is all moles of sulfur. So this 2.13 moles of sulfur will react with the 1.42 moles of iron. Okay. Now we can also set up our table like so. We can say 1.42 moles of iron times 3 moles of sulfur divided by 2 moles of iron. And moles of iron cancel out moles of iron. And again, we'll arrive at the same answer, 2.13 moles of sulfur. Now, this setup, the setup in the table is similar to what we have here. So in the setup, the table setup, the horizontal line is the division line. So this is a division line. And the vertical lines are multiplication. So you see that. So this is our horizontal line, and the multiplication is our vertical line. So it's the same as what we have in the table. Okay, so yeah, so the setup, you can pretty much use the table, or you can use the bottom one. But the beauty of the table is that usually when you set it up, units on the diagonal always cancel. So it makes it easier for you to go back and track your error. So if units on the diagonal don't cancel, then that means that there's something wrong. And the diagonal here is, this is what I mean. So diagonal, like that. So the units always cancel. So as we saw, moles of iron cancels out moles of iron. And we're left with just moles of sulfur. Okay. So thanks for watching.